Hello everyone. For my project, I evolved various robot morphologies in dynamic environments in an attempt to elicit a rugged robot controller and determine which morphology was the most resilient to change. To do this, I made several modifications to the Evolutionary Robotics toolkit we created through Ludobots and introduced some new morphologies inspired by different types of movement. The first morphology tested was the simple quadruped, while the second morphology was a small wheeled car. Finally, the third morphology tested was a wegged robot, inspired by the work done by Joshua Powers, a student in Professor Bongard's lab. The wegged robot is much like the quadruped, except it has wheels for feet. So, each of these morphologies were tested in environments with randomly distributed, sized, and typed objects. These objects spawned outside of a safe zone in which the robot was created and posed as obstacles for the robot's task of single-direction phototaxis. I hypothesized that the wheeled or the wegged robot would perform the best, as it has the legged ability to climb over obstacles while also maintaining the maneuverability of wheels. Each of these environments was very customizable by changing the parameters to the normal distributions that described the positions and size of the obstacles. So finally, I made modifications to the way robots were evolved by introducing single point crossover, in which two robots of the same species could exchange pieces of their genome to sexually reproduce, and by implementing AFPO, Age Fitness Pareto Optimization. In these figures, you can see the AFPO Pareto front. Overall, I found that the wegged robot performed the best. However, it is difficult to conclude definitively because the fitness over several trials for each robot exhibited high standard error. I think in the future, object detection via different colored lights would have greatly aided the robot's abilities to distinguish obstacles from non-obstacles. Thank you for your time.